for the particular extremes, what role did climate change play? How much more or less likely was it due to climate change? The time scale is getting even tighter, even for complex events like hurricanes. So this is a headline from the Washington Post from a couple of months ago. This was, I believe, about 2 days after landfall of Hurricane Ian in South Florida. So it was a major storm. Scientists at Stony Brook University were able to run models and actually make statements about the rainfall for that storm. But what I'm going to do is I'm going to talk about our new tool called the Climate Shift Index. So I'll leave this up for a second if you want to grab the QR code. But the Climate Shift Index is a tool that we developed to really take the techniques that World Weather Attribution and others have used and drive that down and do it every day, everywhere. So not just focusing on the extremes, but really focusing on the weather every day. And for right now, we are focusing on air temperature. But we'll pick other kind of events in a couple of years. So the way this works, this is a map of the United States showing a temperature anomaly, I believe, on July 20th. So the pink areas are areas that are warmer than normal. The blue areas are areas that are cooler than normal. And it's really easy to kind of go and say, okay, well, the warm areas, that's where climate change is having the effect. The blue areas may be less of an effect. But what we're able to do with our system is to make a quantitative statement about each of these locations and what role climate change is playing in those temperatures. And we express that with our new metric, the Climate Shift Index. So the red areas down in the southern part of the graph in Texas, those are areas that are 3 times more likely due to climate change. The yellow areas that you see in the northwest and some in the northeast have a detectable fingerprint of climate change, moving on up into the orange scale, which is level 2 or 2 times as likely. So how do we do this? Well, we start with the distribution of temperature in today's climate, and we're getting that from NOAA's climate forecast system, the CFS climatology. So we get the distribution of temperature for every location on the globe for a 30-day period centered around the day's date. We then remove the signal of global warming and rewind back to a 0-degree climate, a climate with effectively no human-caused global warming. And that gives us that counterfactual distribution, or the gray curve. We do this with several techniques because we want to have a really robust estimate, and this is very similar to the logic that the World Weather Attribution uses. So we have one that focuses on more of an empirical method where we're relating the temperature at a location to global mean temperature. That gives us a slope parameter, which is essentially the local climate sensitivity for that time period, and then we can use that local climate sensitivity to rewind and construct the blue curve, that counterfactual curve. We can also do this more directly using the CMIP6 climate models, which have been run, some forced by extra CO2 and some that have not been forced with CO2. And so we have these paired models, and we can get this really direct comparison. And then we combine those methods together. So going back to our curve, I'm going to go through just a little bit of what the Climate Shift Index scale looks like and then show you the map for today. So the Climate Shift Index begins in the middle at 0. So 0 means that there's effectively no detectable influence of climate change on that day's temperature. It doesn't mean that climate change isn't having an effect. It just means that we can't detect it with the methodology at that particular location. So that gets a 0. We then move up to a 1, which is the first level where we start to feel like we can make those and confident statement that climate change is detectable in the data. And this starts at 1.5 times more likely. Level 2 is 2 times as likely. 3 is 3 times as likely, all the way up to 4 and 5. And we stop at 5 because at that point you really need to use some of the advanced statistics that World Weather Attribution and others are using. But not every day is warm, right? There's some days that are cool, and so we felt like it was very important, especially for our climate communications goals, to actually be able to make a statement on cool days and acknowledge that there's some days that are cool. So we have a symmetric scale, so we have a minus level. So -1 means that it's less likely in our climate with extra greenhouse gases. Level -2 means it's 2 times less likely or half as likely due to climate change, and all the way down. And the key, of course, is that this gives us a way of actually keeping score for a particular location or across the globe. And one of the things that we find, not surprising, is that we get a lot more positives than negatives. But we think it's really important to be able to say sometimes that climate change is not having an effect or not having a detectable effect on a particular event. Okay, so this is the map for today. If you went to our site, which is csi.climatecentral.org, you would be able to see this map. It's a Google Map interface, so you can move around and zoom and pan. You can also go back in time over a little over the last year, and look at any day over the last year. And so the colors are telling you where we are seeing this detectable climate fingerprint. So Saudi Arabia and the Arabian Peninsula has been very warm lately. It does not take a lot of warming in that location to give very strong climate signals because the variance in temperature is very low in that location at this time of year. But you'll notice that Scandinavia has also been running very hot lately, and the northern part of South America as well. Today, a few places that stand out, we have 810 million people across the planet that are experiencing level 3 or higher. Many of these are going to be in China and Southeast Asia, which are big population centers, but they're happening all over the world. We also see some notable cities. For example, Addis Ababa has had 35 days in a row at level 3, so a streak of just very persistent climate change that city is experiencing. And then today we have a collection of really diverse cities, ranging from Nigeria to Mexico City to Sweden to Dubai, right? So huge areas around the globe are experiencing temperatures that have been detected, that we can quantitatively say have been altered by climate change. So thank you. Maybe I could take a couple of questions now, and then we'll switch over to the next speaker. Sorry, 1, 2, and 3.
Could you just switch back to the histogram, the curves, quickly? So just to clarify, the higher number, it's to do with how much more likely it is. It's not just a warmer. It's not related to how much warmer it is.
Exactly. It's how much more likely it is due to climate change. So what this technique is really doing is it's balancing how certain we are about the warming trend at that location with the variance in temperature that you get. So for example, in the United States a couple of weeks ago, we were basically stuck at 0, and that's because that time of year we have very flat warming trends, and we also have a lot of variability. So it would take just a really outstanding event in order to give us a signal. Yeah.
Thank you so much. I have a question about the semantics, because sometimes cold events can also be due to climate change, for example, and in your communication then you have to deal with that. And then the second question is, do you have in the future plans to also include damage in your index somehow? Because the fact that it's a bit warmer right now, for example, in many areas of the world doesn't have any strong impact or something.
Yeah, so I'll take the last question first. So one of the things we are going to be doing is a hindcast going back from 1978 to present, and we will keep that updated. One of the things we really want to do is start to get at some of the damage and impact. So really look at places that have had a persistent high level of our climate shift index, and are those places where we see where we can document damages. And just other work, we're very interested in linking it to impacts as well. To your question about cooling, indeed, that's something that we think we're going to have to deal with a little bit more as we move. We're contemplating an ocean temperature product. So the cooling hole, the blue hole in the North Atlantic is a very robust feature in both the observations and the climate models. And so that's one where if it gets warmer, it would actually be negative on the scale. So negative doesn't necessarily mean cool. In this case, negative means less likely, but for most places, most of the time, it's gonna line up with temperature. All right. I think one more question, and then I'll go to the other speaker. And this is going to be a very short session, so there'll be time to talk to both of us after.
Thank you. Hi, thank you. My question is how you see the role of this tool being used in climate change communication and perception, and sort of the polarization and politicization of the climate crisis. So how we can use this tool as science communicators.
Thank you for that. So we developed this tool very much as a communications product. We released it this summer for the United States. I showed the US maps, and that was because we worked very closely with the community of TV meteorologists in the United States, and we developed it specifically with them in mind. So we had usage in, I believe, about 35 states in the United States this summer, about over 300 kind of unique hits throughout the summer. The global tool, we launched that about 2 weeks ago, and it happened to coincide with when Europe was very, very warm. And so the existence of this tool allowed reporters who were covering that story to put climate change in the headline of those stories, which is something that they and their editors would have really had a hard time doing without some kind of quantitative, independent evaluation. Okay, thank you very much, and I'm going to turn this over to our next speaker, and then both of us will be around to take questions after.
Thank you very much, Andrew. Now our next speaker, his name is Ugo Nanni, and he works at the University of Oslo in glacier instability, and he will tell us, thank you. He's going to tell us about what the glaciers have to say beneath hundreds of meters of the surface. He works in the Alps and also in glaciers in the Arctic. So please, Ugo.
Great. Thank you. Can you hear me well? Yeah, great. So today I wanted to present you both some results that we obtained on glacier in the Arctic, but also a new perspective on listening to the glacier and listening to some voices that were not that common to listen to, and that's why I entitled my presentation The Whispers of Glacier. So you will see through this presentation there will be quite a few QR codes that you can flash and access different information, which could be sounds, but which could be also some article explaining what is the sound of glaciers. So as Sebastian said, I'm working in Oslo in Norway, and I'm mostly focusing on the Arctic glacier, and everything that I'm going to present today has been done in collaboration with different institutions in Norway, among which seismological institution, but also glaciological institution. So I just wanted to start with this image of a flowing glacier. So we talk a lot about glaciers, and sometimes I have the feeling that we think it's static object that can melt or just be present, but actually a glacier is a moving object. And when you look over here, it's 20 years in the Karakoram, which is high mountain Asia. So it's obtained from satellite imagery. You can see that the ice is flowing. And when you see it at this time scale, the ice is actually flowing like the river, or moving like almost an animal or non-human entity. And that's what I wanted to highlight here. It's depending on the perspective you take, then the object we study can have a different meaning. And we can go back like to the simple explanation, why do the glacier is moving and why the glacier is melting. So one part of the glacier, often the upper part, is where the snow accumulates from year to year. And then as the glacier flows down, as it deforms under its own weight, it reaches altitude or latitude, where the sun is so strong that it will melt the ice, and therefore the glaciers start to melt. And when the melt is higher than the accumulation, so where the snow comes, then the glacier will shrink, and this is what we've been explaining in this Cryosphere Pavilion about melting glacier depending on the different temperature. But the mechanism of a glacier, when you see it like this, is quite simple, and you can see that we have different colors and different arrows. Because as the glacier melts, we have the water that can penetrate at the base of the glacier, and Okay, I won't talk too much about the physics, but this is quite important because as the water goes at the base of the glacier, it will lubricate the base of the glacier and might cause unexpected events or maybe collapse of the glacier. So what's happening in response to surface melt is quite important to determine how glacier behaves. Because as the water reaches the bed of the glacier, it could reach the bed and act in different manners. If the bed of the glacier is well organized, then you will have a drainage system as the one you can have on the side of the road, and then the more water won't have any effect. But for some glacier, if you put a little bit of water, then it will be like a slippery road in winter or during rain events. So just to highlight that there is not a strong relationships and a unique relationships. And these non-unique relationships may lead to some unexpected events that are called glacier surge. So again, I take you in the Karakoram, in the same area as before. It's the same timeline, and before you could see that the glacier was gently flowing, just like a normal river. But in this figure, you can see that some of the glacier just fall down to other glacier, like almost if they were collapsing as an instantaneous collapse. And of course, the other end member would be what happened last summer in the European Alps in Italy, where a glacier has been detaching and then falling on a few hikers and mountaineer people. So just to highlight that glacier can be flowing in different manners, and the way the water will influence the glacier really influence the way the water will behave. And what we are doing with my team is to try to understand what can trigger such events, which is both interesting from a scientific point of view, but of course it's interesting from an early warning or maybe a risk analysis. This is a bit just a recall of the headlines that happens in the Alps. And of course it's also recently happened in Pakistan in last May, where a glacier triggered just a big floods and a lot of people were impacted by that. And this is what we are trying to understand, what could be the impact and how could we better understand what's happening. And to do so, I want to introduce you to the method I'm using, which is seismology. You know, seismology for earthquake. So earthquake is, two plates that moves and create a vibration, and then you can put a seismic station and look at ground shaking. But the same thing happened in the ice. As I showed you before, the ice is moving, and of course you can have different processes that will create vibrations that could be recorded. This is why I was telling that I'm listening to the glacier, because when you look at the wave and the ground shaking, it's just as sound, and it travels within the glacier in a similar manner. So we installed this instrument and we went up north. Told you I'm from Norway, so we went up north to Svalbard, where a lot of glaciers are surging, and we are trying to understand what's happening. So of course it's not a place that impacts directly a lot of people, but it's a good place to understand the mechanism, because it's near Norway, but also because there are a lot of glaciers are very sensitive to this surge or collapse events. So it's a really good place to investigate such processes. And we targeted a glacier, so this is my only physical figure of the presentation. The color bars show the time. So green is 20 years ago and pink is now. And okay, well, it's right in front. This is the front of the glacier, and then so the glacier is flowing towards me. It's a 20-kilometer long glacier, and we have observed that over the past 20 years the glacier velocity has been increasing almost by tenfold. Like 20 years ago in the 90s, the glacier was really quiet, and now the glacier starts to accelerate from year to year as it was starting to waking up. That's why I call it the white whale that wakes up, because when you look at him, it looks like a sleeping white whale that is slowly emerging, and maybe will surge and maybe will collapse. So that's why we investigate this glacier, and we install different instruments at different locations where you have the yellow or the green stars. So And here starts the different QR code. You can flash it and you can see in details what we have been doing on this glacier. Just wanted to highlight that what we are doing is accessing to the bed of the glacier, and a glacier is not only a thin layer of water, but here this glacier is more than 300 meters, and that's how you can see that glacier have a huge potential in sea level rise, because it's a huge amount of water that is stored in this glacier up in the Arctic. And what we have been doing is that we have been installing instruments at the base of the glacier, really to understand how well it is coupled or not to the base of the glacier. And that's just some picture from the field. And I just wanted to briefly highlight you what we observe. At the top, so it's 1 year of data of measurement. At the top you have the blue curve that shows the total amount of melt. So surface melts because temperature gets positive during summer. And what I want you to focus on is the black curve at the bottom, which is called the seismic intensity. And it shows that the more melt we have, the more seismic activity we have, because the glacier starts moving, which what I want to highlight here is that with seismic you can really investigate glacier displacement and therefore kind of know a bit before when a glacier is moving or when those glaciers start to move, the same way as we do for earthquake. So what has been done for earthquake for 50 years could be applied now on glacier to monitor them and maybe do some early warning system. And now that I've been showing you some figures and some graphics, I wanted to present you a sound and a little travels to the Arctic and to the bowels of glacier. So it's a 5-minute piece, and I hope the sound will be okay, and I'll let you to this sound. Then I think you can lodge the sound now. Yeah.
Yorkson is a scientific village, so everything that happens here is related to natural science.
Nothing seems to work on a glacier. You can have things working in
La science moderne, quoi, la science cartésienne, quoi. Okay, it's a bit more difficult than I thought to hear it.
Propagates and very impressive record to actually witness. That is something that was actually took many years and many trials.
About these two perspectives, these two friends that comes to the glacier.
Ned mot opp. Vind på flyplassen er fra 80 grader, 14 knop, 1005.
I've always been surprised by things that happened on the glacier.
Because there are a lot of people that think scientists. Like climate change is an opinion. Science is an opinion. Without really seeing the work behind what does happen.
What should I do with this spare geophone?
Collect them all together at one place.
And should I disconnect the geophone that are connected or not?
Can we just have like 30 seconds of silence? Great. So, yeah, sorry. So you can find the sound on SoundCloud, and it was a little travel from southern Europe, from Italy. Maybe you've heard some voices, and going up to the Arctic, towards the interior of the glaciers. So the idea was really to take you towards the glaciers, that you see a lot of numbers, a lot of figures, but to remember that it's also moving objects. And what triggered me to make you hear this today is that 50 years ago we had this album that was called The Song of the Humpback Whales, and you've heard maybe some sounds of the whales during the piece. And this piece of music that was released, what was one of the triggering of the moratory around whaling, because people realized that whales had different sensitivities, and the fact that they could hear it made people change. So maybe with the sound of the glacier we could do something a bit similar, and just knowing that it's not just numbers or objects, but just opening a new perspective by listening to the Arctic and the glaciers. Thank you.
So, if anyone has any questions right now for Ugo,
So, ironically, I used to do whale acoustics. So I'm really interested in, have you been able to string together a longer recording and do things like look at annual cycles or diurnal cycles in the changes in the sound?
Yeah. So the question was like, do we have longer term record? So basically every measurement we do can be transformed in a sound. So we have years of glacier sounds. And what we start to see is that some places become more and more quiet because the glaciers start to disappear, while places start to be more and more active because glaciers are accelerating and collapsing. So it's a lot of sounds now. I think we can cut down the questions and just listen to this.
okay, any more questions for Ugo?
Yeah, thank you, Ugo. That was fantastic. I have a quick question for you. How have people reacted to these sounds? Here we are at the Cryosphere Pavilion. There are quite a few glaciologists in the audience. What about the general public? What about policymakers that you may have met? What has been their reaction to these sounds? Were they surprised, for example, by listening to how active these glaciers could be?
Yeah, so I haven't met a lot of policymakers yet, but I'm hoping that these sounds will come to their ears. But most of the people I've met, which is more like civil society and a lot of kids and teachers, were surprised by the sound, that it makes a sound. And there were like some kids who were saying, oh, it's alive. And I think it was the main impression that I had, is that everyone was like, oh, it's something that is actually moving and making sounds like it's crying. So that was most of the results. But I'm looking forward for policymakers to hear to this. Thank you.
Okay. If you have any more comments, we can gather here and talk with the presenters.
Maybe I don't know if there is some more question or.